like to present the space crew of mission STARS. STARS is a team of three space enthusiasts launched by SSERD. So their objective was to develop an app which would suggest the user the instrument he can use in his payload for his mission to a specific destination using a database of major payloads instrument used for the space exploration. So now I would like to welcome the team stars. Over to you guys. All the best.
So, good evening, everyone. We, the team stars, bring to you our mission for this internship batch 4 from SSERD team. So, the topic we chose for our internship was space mission design, and the problem statement that we had in front of us was nothing but to develop an app for phase A studies. So, let's move on with the presentation. So, our team name is STARS. So what the STARS stand for is Shipment Tools Assistant for Rockets. So basically, it is a tool that will give user it will give the user the recommendations of the instruments he or she can use in his space missions. So it is a payload tool.
जो हम चौथी कक्षा में पढ़ते थे वो याद दिला देता हूँ. ये हम हैं और ये चांद यहाँ है और ये जो मार्स है ये यहाँ इतनी दूर.
सर हम मार्स जा सकते हैं.
That was our space song for the day. We followed the SSERD tradition, and this song was dedicated to all the space scientists around the world. Moving forward with our presentation, so a small quote that space is spacious and precious. So we should also explore it and also keep it to ourselves and not let others conquer the space, because space is for us. So these are our team members. So I am Varun Gokhale, the team lead. We have Juan Pablo Teleria Ocando from Mexico, who is our assistant team lead, and we have Adarsh Pillai, who is also the member of the team. And now let me introduce you to our superstar mentors. So we have Vishnuvardhan Shaktibala, who is our mentor. Also we have Rashika SN, and finally our team coordinator Anisha. Moving on to the presentation. These are the main points of discussion for today's presentation. So we would be starting with introduction, the mission statement, mission objective, the project timeline, followed by database development, app development, future goals, team reviews, and credits. Moving on, introduction. So as we all know that space mission design is quite a tricky topic to work on, and it is a quite tricky subject to work, as it is very time consuming and it takes several years to plan an entire space mission and then accordingly work on it. So it needs specific resources, some very advanced technology and knowledge related to similar missions that would help scientists to design one. So even world-renowned space agencies have same problem, that when it comes to planning missions, it takes a longer time, and in this process, many of the space agencies just reinvent their previous mission. That is what happens. So what we intend to do is to bring out a new way to help connect and share knowledge, about similar technologies which have instruments that can help scientists reduce the time consumed while planning a space mission. So that goes to the introduction part. So the mission statement. So the mission statement that our mentors had provided us was to design a tool for space mission phase A studies. So what does this statement exactly mean? What does phase A exactly mean? So phase A is basically the analysis part of your mission, basically the POC, proof of concept part of any space mission. So there are two stages basically. So there is a pre-phase A and there's a phase A. So in pre-phase A, you do all the rough work or the rough idea around what your mission is going to be about. And when it comes to phase A, then you start analyzing, or you try to build up a proof of concept where you try to bring in what devices you would be using, what instruments you would be using, what would be the trajectory of your rocket, what would be the rest parameters for propulsion. You have separate values for calculation. You have a lot of calculation to do, and all that stuff comes under phase A studies. So we had to design a tool for space mission phase A studies. So instead of narrowing it, instead of using the entire rocket collectively, we tried to narrow it down to only the payloads of the rocket, because finally they are the ones which go into the space and do the majority of the work. Coming to the mission objective, so the mission objective was to develop an app which includes database of major instruments used in payloads available in space industries. So it also suggested that we survey past, present, and future space missions, and we try to correlate the mission objective with each instrument used. These missions also included missions that were successful and also missions that failed. So the final goal of the project is to help space mission design analysts to get a first-hand idea of the possible instruments that can be selected for payload once the destination of the mission is decided. So coming to the project timeline. So this flowchart kind of explains the entire procedure what we had followed to like build our app. So initially we started with the literature study. So when we started with literature study, the point which came front in front of us was the destination that we were supposed to choose, because we were allotted 5 missions by the mentors and minimum of 5 missions. So you can take maximum n number of missions. So we selected 6 missions per destination. So we had 3 destinations which we took into consideration, as these 3 destinations are the most widely space mission designed destinations. So for these 3 destinations were Earth, Mars, and Moon. So accordingly, we studied all the possible successful, unsuccessful, present, past, and future missions to Earth, Mars, and Moon, and accordingly then tabulated data according to a certain structure. After all this, we did an environmental analysis in which we like did groundwork study on how the environment is on Earth, Moon, and Mars. Though we know how environment is there on Earth, but we need to study it the very minute way, because it is finally, unless we understand how the environment is, we would not be able to suggest or recommend instruments to space design analysts. So after all this, we then after collecting or after tabulating the entire data, we then moved forward to app development, and that app development led to the Stars app version 1, which was ready for testing. Moving on, so now getting into database development, this will be explained by Adarsh.
Okay. Hi guys. Before the app development, we built our database, and on the screen you can see the data points that we chose. So all these are the data points, and for each point, we referred multiple research papers, sites of ESA, JAXA, or NASA, or ISRO, and we chose each of them. And it for some missions or some instruments, it wasn't possible for us to find each and every data point, so then we left those out to be filled in the future. And this is how we built our Excel sheet, putting the data under each category. And yeah, so you can see that, and this is our is a ratio of each target, that is the Moon, Earth, and Mars. And we could have had more missions or more instruments, but even for places like Earth, for some instruments, it was very hard to find data. I don't know why. It's kind of hard to do that, but it was a good experience. So yeah, it was there, and I think in the future we can actually add more data into the app.
So this is the flowchart of the application which we intend to provide to the user. So initially, the user decides the destination for his mission. So because in space mission design, the destination is very important, because unless you choose a destination, you are very uncertain about what instruments you would be using and how you will be chalking out your entire mission design. So first the user enters the destination of his mission, then the user enters his or her objective or task that he or she wishes to perform during that particular mission. It might be anything. It might be imagery, spectrometry, it might be radiometry, it might be communications. So this entire thing depends on the user. So the user decides, because finally it is the user who would be using our app for space mission design or to choose his instrument. So he would have a clear picture of what he wishes to do in that particular mission, and accordingly, after entering that data, instruments will be displayed according to the data specified by the user. And then that data or the instruments that are displayed have all these three parameters. They have the images of that in particular instrument. They have also have the data sheet of the instrument, which I'll be showing in further slides how the data sheet looks like. And then coming to the compatibility of the instrument. So the compatibility of the instrument is also displayed, but this is one of our future goals that we intend to do. So moving on, so this was our first prototype of the app using Microsoft Power Apps. Doing or making building an app using Microsoft Power Apps was pretty tedious, and so we had to search for an alternative which was simpler and easy and also very user friendly. It also had something which was literally beautiful to display. So the second prototype that we designed was using Glide apps. So as you can see on the screen, this is our home screen that the user will get into whenever he enters the app. So he has three destinations: Mars, Moon, and Earth. Then he has a separate entry for mission objective, instrument task, operator, and status. So he can, all these four fields are not mandatory. The user can fill any of these fields and then ask the app to show recommendations. So if the user wants, he can just enter the mission objective or just the instrument task, just the operator of the mission, and the app would filter out data for the user. So these are some, this is how the app would show instruments. So as you can see, this is high rise. It is an instrument that was used in Mars Reconnaissance Orbiter, uh, Ball Aerospace, and this was used for imagery. Uh, so this is how it is displayed, and in the next slide I'll be showing you how it works. This is how data is displayed on the stars app. As you can see, there are a lot of instruments that are displayed in this app. User can pick his or her instrument according to his choice. He can just search the instrument that he wants, and then all these details would be shown to him. And if the user is not very keen or is not confirmed with his final instrument, he can save that instrument in his favorites, which he can later view whenever he logs into the app again. So all that data would be saved so that the user does not have any problem while using the app. This is how data is displayed on the stars app. You can search according to anything, any parameter you choose, and you will get the results. So this is the user guide of how the final application looks like. We have a short demo video on how the app would look like. So for example, if we select the mission destination as Mars and mission objective as color and operator as NASA, might be operational also. So the status is operational, and then you click on show me recommendations. This is the recommendations that are displayed to you by the app. Then you can like click on to any of the instrument that you wish to further view, and then accordingly find out the instrument details, like this prism camera, visible and near infrared spectrometer. So you have all the details, the main task, you have the instrument mass, you have the power consumed, you have the components that were associated, you have also the sources from where this data was brought uh, into the to the user. So it's like you can select any field of your choice. It is not mandatory that you have only one entry. You can have multiple entries also. So this is how our final app would work after the user specifies his or her objectives. So moving on. So these are our future goals that we plan to implement. So first and foremost is the compatibility factor, which we already told in the previous slide, that this feature would suggest the user how compatible is a particular instrument according to his or her mission objective. So how would this compatibility factor be calculated? So it is that majority of the space missions to a certain destination have instruments of the similar kind. Like when you compare one of NASA's mission, for example, LADI, there's a mission called LADI, or there is a lunar robotics program mission where you have the L-cross orbiter, and where you have the L-cross satellite, and there is also a rover. Sorry, there is also another orbiter. So it has similar instruments like the near infrared spectrometer that was used in this L-cross, and this same instrument you would be finding it in Chandrayaan 1 and Chandrayaan 2 missions of the ISRO. So there are majority of instruments used for the same objective are found to be repetitive in many of the space missions. So only there are some minor tweaks that are being done to that instrument to uh, enhance its ability or enhance its uh, objective. So basically we would be comparing all that versions, and we would be providing the user the best uh, instrument. And next goal would be multiple destinations. So for the time being we had only tabulated Earth, Mars and Moon. Might be in the future versions of the app you could go up to, you can have Venus also, you can have Jupiter, Saturn, and you can also have asteroids. So you can have various, even you can have the moons of Jupiter. If there are any further future space missions to these destinations, surely they would be added. And more wide range of data. So why more wide range of data? As missions and destination increase, the amount of instruments would increase. That is understood, but that would increase. That would result in wide range of data for the user to choose, and that will also give a 100% compatibility factor. That would give a instrument that would have a greater compatibility factor, because then there would be for one objective there would be 100 choices. So it would be very easy for the user to like pick the best among it and use it for his mission. So these are the team reviews. So my experience is indeed a special one, as this is my first space related internship. It was the first time I was given the responsibility to lead the team, and I feel I have done some justice to my role, though we had some highs and lows during the entire period. And all thanks to my fellow mate Juan, who was the most active member of the crew and also the assistant team lead. His quick way of working helped us completing our mission well on time. It was the first time we worked on building apps that would be useful for scientists in future missions. So I'll just read out Juan's experience also. So he was able to put in practice skills that usually are not related with space development, such as database creation, administration, and apps development, and use them in a way that can be useful for space related context in the space mission design. He also learned that teamwork can be difficult, especially when working remotely from the other side of the world. And he had a lot of challenges and situations that we had to all to solve together. But we are glad with the final result. Now others would like give his experience.
Yeah, okay. So to me, the internship was a new experience. This is the first time in my life that I genuinely made an effort to meet deadlines. Okay, some of the work is quite annoying, actually, seriously, very annoying. But yeah, so when it's like everything's over, like I'm pretty sure I'll miss it. And yeah, Pavan is hilarious. That's it. Yeah, thanks.
So the credits. Firstly, our entire team would like to thank our mentors Vishnu and Rashika for guiding us throughout the project. Some uh, very interesting things. We would be surely missing Vishnu's wide range of suggestions, because he would always have lot of ideas and lot of suggestions that he would give us as our mentor, and that those suggestions are really helpful when you go into developing your project. We would also like to thank our coordinator Anisha for helping us glide through this internship smoothly. We would also like to thank the entire SSERD team for helping us in all possible ways to complete our project by providing us with all required resources. And a special thanks to Mr. Pawan Kumar for guiding us through all the necessary requirements for building our career. Thank you. Any questions?
Thank you, Team Stars, for a wonderful presentation. Now I would like to ask audience to shoot up some questions today. Mm, I guess no questions from the audience for you guys. So thank you so much for your presentation and your time.
Thank you.